Hello everyone. In this video I'm going to take a look at the exercises in Chapter 8 of your textbook. Again, I'll do the odd numbered ones. And then if you want to practice on your own, you can go ahead and do the even numbered ones as well. In this section of the chapters, or of the textbook, what we're doing is we're looking at the idea of confidence intervals around a mean. And for the most part, I'm just going to stick with the 95% confidence intervals. So question number 1. For each of the following situations, calculate a 95% confidence interval for the mean. Sigma is not known. So we're going to have to use our sample standard error. Beginning with the step, calculate the degrees of freedom and identify the critical value of t. So hopefully you'll have your t-tables out. I do not have a t-table out, so I will have to use the book. Okay. Let's look at the first one. N equals 15. If I'm going to calculate the degrees of freedom for A, degrees of freedom equals n minus 1. I have degrees of freedom equals 15 minus 1, 14 degrees of freedom. And identify the critical value of t. So for 95% confidence, I'm going to use the column that has 0.025 in the tails, because I've got two tails. And for 14 degrees of freedom, the critical value is, let's see, t equals 2.145. Now if I'm going to construct a 95% confidence interval around that, the confidence interval is equal to x bar plus or minus t times my standard error. Okay, so my confidence interval is going to equal 6.00 plus and minus 2.145 times 1.50. I have to do my multiplication before I do my addition. 2.145 times 1.5 equals 3.2175 plus or minus 6. So my confidence interval, or my range of values, let's start with the smallest one, 6 minus 3.2175 is going to be a 2.7825. Let's call that 2.78. And my upper bound is going to be 6 plus 3.2175, which is a 9.22. Okay. 2.78, 9.22. So stepwise, first we did the degrees of freedom. Second, we looked what t was. And third, we used the equation. Let's look at number 3. For each of the following sets of numbers, calculate a 95% confidence interval for the mean, sigma not known. Before going through the steps and calculating the confidence interval, the sample mean and standard deviation must first be calculated. Okay, I'm going to do the easy one. I'm going to do 3a, and I'll do that over here. So here's my values of x: 7, 2, 5, 9, 6, 6. The next thing I'm going to calculate is the sum of x. So 7 plus 2, let's clear that, 7 plus 2 plus 5 plus 9 plus 6 plus 6. The sum of x is 35. My n is 1, 2, 3, 4, 5, 6. 35 divided by 6 leaves me with an x bar of 5.83. Now, in order to calculate the standard deviation, the next step is to do x minus x bar. 7 minus 5.83. 2 minus 5.83 is a negative 3.83. Now, if I'm smart, while I have the answers on my calculator, I better just go ahead and square them. So I'm going to take a step back now that I think about it. 3, 6, 8, 9, let's call that 1.37. And 3.83 times 3.83, 14.67. Okay, back to this. 5 minus 5.83 should be a negative 0.83. Squared is a positive 6.889. Let's call that a positive 6.9. 9 minus 5.83 is 3.17. If I square that, I get 10.0489. Let's call that 10.05. And my last one, 6 minus 5.83 is a 0.17. Squared is 0.0289, so let's call that a 3. Alright. I should have written down the equation for the standard deviation. That might actually be helpful. And it is S equals the sum of x minus x bar squared divided by n minus 1, taking the square root of that. Okay, got that correct. So now I have to sum all of these. Okay, I got the sum of the squares. That is 2684 divided by n minus 1. N was 6. So let's divide that by 5. That is 5.368. Take the square root of that. Remember, turn your phone sideways for the square root button. .316. So let's call that up 2.32. So my value for S is going to be 2.32. Okay, let's make some room. What's the next step? 95% confidence interval. So my confidence interval, I do not know sigma. I have mean, so it's going to be x bar plus or minus the critical value of t times the standard error. So I've got two more things to figure out. The first is, what is t? Well, if I have an n of 6, degrees of freedom are going to equal 5. So let's go into the table and I'm looking on, so in your textbook, this is page T18. I have 5 degrees of freedom for a two-tailed test. My t-value is 2.571. And your textbook has 2 columns. It has one for a one-tailed test and another one for a two-tailed test. So that's why I'm using the two-tailed test with 5% significance. Okay. Let's now, what do I need? Oh, my standard error. So my standard error I calculate by doing, where to put this? Let's put it down here. Okay. Standard error is the variance, 2.32 divided by the square root of 6. Grabbing our calculators. The square root of 6 is 2.45. So 2.32 divided by 2.45 equals 0.99469. So let's call that 0.95 if we're going to round. I think I have everything I need for my confidence interval. Confidence interval equals x bar is 5.83. That's the mean we got earlier. Plus or minus my critical value of t, 2.571, times the standard error that I just computed, 0.95. Okay. So let's do math. What do we do first? Between addition, subtraction, and multiplication, we do the multiplication first. 2.571 times 0.95. That is 2.4424, so I'll leave that, 2.44. And we'll take our mean, 5.83. And we'll first subtract to get the lower bound. And that is 3.39. And for the upper bound, we will 5.8 add our 2.44 and get 8.27. So our range is, our confidence interval is between 3.39 and 8.27. This one took a little while because I had to go ahead and I wasn't given the mean and the standard deviation of my sample. I had to go ahead and calculate those. If you are a glutton for punishment and you want to walk through this yourself, go ahead and let's do B. That seems like a reasonable one. And I will go ahead and hit pause. And when you come back, I will give you the answers. Remember, you hit pause. You were going to try this on your own. Okay. Hopefully you did well. So for 3B, the mean you should have gotten was 9.25. You should have gotten an S of 3.69. Standard error is 1.31. Degrees of freedom is 7. Your value of t is 2.365. And the 95% confidence interval ranged from 6.15 to 12.35. So hopefully you are close. Let's go on to the next one. For each of the following sets of numbers, calculate a 95% confidence interval for the mean. Before going through the steps, the sample mean and standard deviations must be calculated. Next, draw a conclusion about each confidence interval. Nope, we just did that. But if you're going to hit pause and do one on your own, try 5B. And when you come back, x bar equals 5.00, s equals 2.83, s of x equals 1.00. There were 7 degrees of freedom. Your value of t is 2.365. The confidence interval is, we are 95% confident that the interval of 2.64 to 7.37 contains the population mean. That was 5B. I know I'm cheating by not doing all these. Okay, 7. In an earlier salary survey, 73 of the respondents received their master's degrees in a 10-year period. Listed below are the descriptive statistics of the income of the two genders. Calculate two 95% confidence intervals, one for males and one for females. For each gender, state the desired level of confidence. Well, that's easy. That's 95%. Calculate the confidence interval and confidence limits. Calculate the standard error of the mean. Calculate the degrees of freedom, t, and then go ahead. All right, so let's do this. Let's start with the men. So for males, degrees of freedom equals, if n is 33, I have 32 degrees of freedom. For 32 degrees of freedom, let's go ahead and look in the critical value table. 32, of course, my table stops at 30. Great. How do they expect you to do this? Well, let's use the closest one. Let's use 30. 2.042. Go ahead and use that one. If your table goes to 32, we'll use whatever value you have. We're close. What else do we need to compute? We do need to compute the standard error. So that's going to be 41,845 divided by the square root of n. So it's square root of 35. Go ahead and calculate that. Square root of 33 equals 5.744. That's 5.74. Okay. 41,845 divided by 5.74 equals 7290.07. If we want to get really specific. So I've got my critical value t, I've got my standard error. My confidence interval is going to be the average, which is 7727 plus and minus 2.042 times 7290.07. So I do my multiplication first. $14,886.3229, so we'll round that to 32. So we take our mean, 77.27, and first we subtract 6. Okay, and the lower limit, let's do males, 55, 8, 40, and 68 cents. That's the lower limit. I'm going to go back to my equation and add 70727 plus 14886 and 32 cents. 85,613.32. So there's my range, my confidence interval for the males. Let's do the females next. Get myself a workspace. Excuse me. So for females, we're going to stick with that 95% confidence. Degrees of freedom is 39. Here's the mean, standard deviation. We're going to have to do the standard error. And we're going to have to come up with T, the critical value of T for 95% with 39 degrees of freedom. Standard error is S divided by the square root of n, which equals 30,1082 divided by the square root of 40. So let's hit the calculator. The square root of 40, 6.32245 and 32. Let's go ahead and do that next. 30,182 divided by my 6.32, and my standard error is 4775.6329, which rounds to 63 cents. Now for my critical values, again, if I go back to my table in the book, 39 degrees of freedom does not exist. So here's what I'm going to do for this. I am going to go ahead and let me just double check actually, because it started to do it by tens. Yep, 2 point. I'm going to use the same value, 2.042. Okay. Now to construct my confidence interval, take my sample mean, which is 63, plus or minus 2.042 times 3. There we go. So I'm going to multiply that out. 2.042 times 4775.63. That's my standard error. $9,751.364, so 84 cents by rounding. So my first confidence interval is going to be subtraction, 63,200 minus 9,751.84, 53,448.16 for females, that's lower limit. And the next one is to calculate it by adding 63,200 plus 9,751.84 cents, 72,951.84 cents. So what do we have? We have a 95% probability that this interval contains the mean income, the mean population income for females who recently received their degree, and the corresponding value for males. So there we go. Number 9. For each of the following situations, calculate a 95% confidence interval for the mean. We know sigma. Beginning with the step, identify the critical value of z. So we have information on the population now, and we're not given sample size. So now we got the equation that it's going to use a z-score. So our confidence interval is going to equal our mean plus and minus z times our given standard error. Less work for us. Let's just go ahead and do 9c. Critical value of z for 95% confidence interval is our magic number of 1.96. So for c, the confidence interval equals x bar, which is 26.40 plus and minus 1.96 times 1.05. So I'm using the equation of x bar plus or minus z and times standard error. So hop on the calculator. 1.96 times 1.05 is a 2.058 or 2.06. We're going to be consistent with our rounding. And our confidence interval is going to range from 26.40 minus 2.06, which is 24.34, to our 26.40 plus 2.06, to 28.46. And that's how you do a confidence interval, because that's all we've been doing this section. Let's look at another one. Actually, no. Hit pause and do D. For D, you should look like this. Confidence interval equals 112.00 plus and minus 1.96 times 1013. Your answers are 92.15 to 131.85. So that's what you should have got if you did D. I hope you guys are pausing these and doing some work, not just watching me. It's got to be boring. Number 11. For each of the following sets of numbers, calculate a 95% confidence interval for the mean. Sigma is known. Before going through the steps in calculating the confidence interval, the sample mean and standard deviation must first be calculated. Next, draw a conclusion about each confidence interval. Okay. Oh, what do I want to do here? Here's what I'm going to do. I'm just going to plow through these. So let's go ahead and, without writing everything down, grab our calculators. And for A, let's calculate X. Nine plus 2 plus 8 plus 16 plus 7 plus 4 plus 12. That equals 58. Divided by, we had 7 numbers. So our sample mean is 8.29. So if they gave me a sigma, do I really need to calculate S? Let's find out. So this sigma is equal to, if we assume it's equal to 5, square root of n was 7. 5 divided by the square root of 7 is 1.889, so it's 1.89. Okay. Yeah, I don't need to calculate S. You're not going to make me do extra work. If we are given a population to assume, let's assume it. Okay, so 1.89. So my confidence interval is now going to be my mean plus and minus my z-score times my standard error. Plus or minus, what's my mean? That was 8.29. Plus or minus my 1.96 times 1.89. So let's figure out the multiplication first. 1.96 times 1.89, which is almost 2 times 2. Let's see, 3.704, that's 3.70. So again, for the calculation of a confidence interval, you have to do it twice. 8.29 minus 3.7 is our lower bound, and that is 4.59 to 8.29 plus 3.7. That's our upper bound, is 11.99. So we are 95% confident that the interval of this contains the population mean. There we go. Here's a familiar example. Chapter 7 referred to a program designed to improve scores on the GRE. The class had 25 students. Scored a mean of 1075. Assuming the population standard deviation is 200, thank you, that saves me from calculating something. Estimate the mean GRE score for the population of students by calculating the 95% confidence interval for the mean. Select the desired level of confidence. Well, that's easy, 95%. You just told us to do that. Now we have population standard error. We have this 200. Okay, calculate the confidence interval by step 1. Calculate the population standard error of the mean. Okay, so first step, first question. 200 divided by the square root of 25. Square root of 25 is 5. And this should be 40. Identify the critical value of z. Easy, 1.96. Calculate the confidence interval and confidence limits. Okay. We all have this memorized by now. X bar plus or minus z times standard error. Confidence interval equals, my average was 1075, plus or minus 1.96 times 40. 1.96 times 40, doing a multiplication first, is 78.4. So the lower range is going to be 1075 minus 78.4, because it's a plus and a minus. 996.6, and 1075 plus 78.4 is 1153.4. That's our confidence interval. And we have a 95% probability. The sample mean is in here. There we go. Okay. I love chocolate chip cookies. Like, favorite cookie. If I'm gonna have a sweet tooth craving, gonna make cookies, chocolate chip. Not a huge fan of Chips Ahoy because I like my chocolate chip cookies soft, but I like chocolate chip cookies. So I like this example. In the Chips Ahoy cookie example from the previous chapter, a 95% confidence interval was constructed for 18 bags of cookies. So this example is the number of chips in a bag of cookies. Assuming the mean and standard deviation remain the same, what's the confidence interval for the mean of 36 bags rather than 18? Well, we didn't do number 6 because that was an even numbered one. So let's just go ahead and do this. We have our mean, we have our S, but we need to do the standard error. So the standard error is going to be 114.01 divided by the square root of, we got 36 bags, which means 6. 114.01 divided by 6 is 19.001. So that rounds to 00. So our confidence interval is, well, if n is 36, my critical value, I gotta look that up because it's a t-score, right? Sample. My critical value for t, and 36 isn't in my table, but so I'll use 2.042 as my critical value. So my confidence interval equals my mean plus or minus t times my, oops, got a sample, wrong letter, S, my standard error. So where are we? X bar, 1,261 chocolate chip cookies, chocolate chips in the cookies, plus or minus 2.042 times 19.00, 2.0442 times my 19, that equals 38.798. So that is actually going to round up to 3880. We've got two values to compute. 1261 minus 38.80, 1,222.2 chocolate chips, and 1261 plus 38.80. There we go. That's our confidence interval. Part B, what is the confidence interval for the mean of n equals 200 bags rather than 18? So let's think about where this actually matters. If n is 200, let's go back up here. Let's just take this, put in a 200. because that's where we used n first. So if we take that out, let's find out what the square root of 200 is. It is 14.142. So 114.01 divided by 14.14 is 8.062. So we cut the standard error from 19 down to 8. And as a result, when we plug that 8 in here, we're going to have 8.06. The distance away from the center of our distribution is going to get smaller. So this 38 that we're going to subtract is actually going to be 16.45. Okay. Now there's one more thing that would change. If we have an n of 200, that's huge. Right? We are going to pretty much revert to my 1.96. There's a small little quirk though. If you look up the answer in your book, it's going to tell you to use 1.98. And that's because the book's t-table goes up to 120 degrees of freedom. So that's why if you look at the answer in the book, it's going to say 1.98. 1.98, 1.96, we're not going to be far off. I mean, I'm not going to quibble over 2 or 3 chips missing from a bag. As a result, the confidence intervals are also going to change. So I'm going to use the book's 1.98 times 8.06 plus or minus 15.96 chips. 1261 minus 15.96 and 1,261 plus 15.96 chips. Not sure where my old answers went. Oops, that's not my old answers. They were so what happened? Well, the band gets narrower as the sample gets larger. So we're sort of honing in. The width gets smaller. So you want a larger sample size. We can estimate the population with better precision. That's what we want. So number 17. In the cookie example, a confidence interval with 100 was constructed when we did 18 using the standard deviation as the estimate of the population's standard deviation. How large should the sample be for a desired 95% confidence interval width of 50 chips? Alright, this is when I was in class, or in the video, I told you, you'll never have to do this, because I won't ask you to do it. But I'll show you how you can do it. The equation is n prime, so we're guessing at the number, z sigma hat over confidence interval divided by 2 squared. Okay, now a couple of these things are new, slightly new. Z, for a 95% confidence interval, that is 1.96. That sigma with a little hat is when we're saying we're going to take our sample and we're going to assume, right? We're going to make an assumption that that's an estimate of the population standard deviation. Now the confidence interval is going to have a width of how many chips? 50 chips divided by 2. Okay. Squared. Alright, so it looks a little nasty because if you notice we're dividing a number and then dividing it again. And I've never really talked a lot about the hat guys before either. So let's go ahead and do the math. 1.96 times 114.01 is 223.4596. Let's call that 46. Divided by 50 divided by 2. I don't need the calculator. Now let's do this. What's inside this parentheses? 223.46 divided by 25. It's 8.9384. So that's actually a 94. Squared. 8.94 squared. 79.92. We should have 80 people. So we need to break open 80 bags of Chips Ahoy chips if we want to know what the population mean is with a range of 50 chips. And that's all that is. Okay? One more. Number 23. A pediatrician wants to estimate the average temperature of children to come to her for treatment. She records the temperature of 23 kids, n equals 23. Calculates a mean from her sample of 98.83 with a standard deviation of 2.11 degrees. Calculate the 90, 95, and 99% confidence interval for the mean. We do not know what that is. The population standard deviation for her data. Okay. I'm going to do 95. Actually, no. I'll do it the right way. I was going to get touchy and only do it one way. So our n is 23, so our degrees of freedom are 22 degrees of freedom. Okay. Confidence interval equals x bar plus or minus your value of t times, standard error. Better go back and compute that. Standard error equals 2.11 divided by the square root of n. Calculator. Square root of 23 is 4.79795. So let's make that 4.80. 2.11 divided by 4.80 equals 4395 to 0.44. Okay, I left t there for a reason. So what I want you to do is look at your t table. We have 22 degrees of freedom. The value that we put in for t is going to depend upon what confidence interval we want. The 90% confidence interval for 22 degrees of freedom, the value of t is 1.717. For 95%, it is 2.074. And for 99% confidence, it is 2.819. So I'm going to do the 95% one. Do my math first. Multiplication. 2.074 times 0.44. Give me a nasty error because I have clumsy fingers. There we go. 91912, so we'll do 0.91. .83 minus 0.91 is 97.92 to 99.74. So if I go through and I change the t, if I make t bigger, what's going to happen? Well, my band is going to get, if I make t bigger, right, make that bigger, my band is going to get wider. Thank goodness. Because if I want the most confidence, I'm going to have to make it bigger so that I don't make a mistake. Alright, I'm done for this section. Very simple, right? If you can just understand, really the hardest thing is knowing which value to plug in as your critical value and then not forgetting to go ahead and take the standard error. Hope you do some of the questions on your own. If you want to, feel free to stop by my office hours, Mondays and Wednesdays, and 9 to 11, and we'll take a look at this.